Just to introduce myself, my name is Gary Russell. I'm the project lead on Spring Integration and Spring AMQP. I've done a fair amount of work in Spring XD as well. Mark Fisher, who began the Spring Integration project, handed the reins over to me a couple of years ago when he started working on what has become Spring XD. Before we get into the talk proper, can I get an idea of who's actually using Spring Integration? Okay, and XD, a few less, and RabbitMQ. Okay, good. So, as I said, Mark moved over a couple of years ago and started working on XD, and I'll talk a little bit about what XD is. Before we do that, did anybody go to Mark's talk yesterday afternoon, Spring Cloud Streams? Okay, so there might have been a bit of concern that XD is kind of going away, but it's not. I mean, it's just really being renamed and a little bit of re-architecting. And there was a blog post put out today, actually late last night, that really discusses, you know, what the evolution process is, and just really to explain that Spring Cloud Data Flow is really just an evolution of what is today Spring XD or Spring XD 1.0. So it'll be like XD 2.0, but there's a name change in there. So there's really nothing to be concerned about. So what I would like to talk about today is specifically how Spring Integration is used within XD, not only for individual components, modules, but actually within the XD process itself to wire those modules together. So it's heavily based on Spring Integration. So with that, let's just take a quick spin through XD for those of you that don't know what it is. So that's the usual legal stuff. Within XD, we have a number of components, and as I said, each one is it's really a very overused term, microservice, but each component within a stream within XD is a small, typically small Spring Integration application context, and XD itself wires these components together. And there are three types of components. There is a source, which is typically an inbound channel adapter of some kind, maybe FTP or HTTP, and a single channel, which is an output channel. So it's typically an inbound channel adapter and a channel called output. We take a stream, as we construct a stream, we can then pass that data onto a processor, which typically has got one or more endpoints within it, and an input channel and an output channel. And then the third type of component is a sink, which typically is just an input channel and some kind of outbound channel adapter, maybe like the HDFS sink is to write the data into HDFS. So, well, there are a number of obviously out-of-the-box modules, and when we wire them together into a stream. And here we have an HTTP source, some transformation that's performed on it by the transform processor, and we're just writing it to the log. And in XD terms, the pipe between the components is provided by a message bus. The message bus, we have three implementations currently: the RabbitMQ message bus, a Redis-based bus, and a Kafka-based bus. In this talk, we're really only going to be talking about the RabbitMQ. What I want to try and describe is how we're using RabbitMQ internally, how we provision RabbitMQ, how we deal with dead letter queues and provisioning of those, and all the other components within here. So that's really what we're going to be talking about is that wiring together of these components into a stream. So a message bus, that we're going to really look at two methods really. We have consumers and producers. So Something that's a source is obviously a producer. It's creating data, sending it to the message bus. A sink is just a consumer that consumes data from the message bus and does with it what it wants to. And then, of course, has both producers and consumers, or consumers and producers, because it typically, as we bind these modules together, we deploy them right to left. So we'll deploy the sink first and then start it, then we'll deploy the processor, start it, and then we'll deploy the source and start that. So these are the two key methods. Now, if you were at Mark's talk yesterday about, let me just jump out of here, about Spring Cloud Stream, everything I'm going to talk about today is going to be pretty much exactly the way it will work in Spring Cloud Stream. The difference is instead of being a message bus now, we have this component called a binder. And as you can see, it's got just exact same methods: bind consumer, bind producer. It's just that now, instead of having these mini application contexts all loaded within the same JVM, we're really binding them to the external broker, in this case RabbitMQ. So again, there's really no difference in the architecture from the perspective of binding the modules together. The other thing that we need to talk about briefly is when we configure our XD container, or it'll be the cloud properties, there's a number of things that we want to set up by default. Now, all of these can be overridden on an individual stream basis when you deploy a stream, but the key ones that we're going to talk about today is auto bind DLQ. What does that mean? When that's set to true, it defaults to false. Well, let me take a step back. When we bind a let's start with a consumer. When we bind a consumer to the message bus, first thing we need to do is create or declare a queue in RabbitMQ that's going to be the pipe that's going to transport the data between the modules. So we create the queue. If auto bind DLQ is set to true, then we configure that queue with a dead letter exchange, and we also provision a dead letter queue, and we set up the routing for that. What that enables us to do is that if there's a failure in a processor or in a sink of some kind, together with a bunch of retry algorithms using the spring-retry project, we will cause the message to be routed to the dead letter queue, so that we don't lose messages. That's the main reason there. If you don't have auto bind DLQ true, then after the retries are exhausted, those messages are simply dropped. So it depends on your application as to whether, if it's critical, you don't want to lose any data, then you would configure this DLQ. Now, there's nothing in XD to do anything with those dead letter messages. They just get dumped into there. It's your responsibility then, or your application would have to deal with those messages somehow, either by routing them back to the main queue or handling them in some other way. But at least the framework will save off those messages. The durable subscription property is an interesting one. This was a change in XD 1.2. XD has a notion of a publish. I said there's bind consumer. We also and bind producer. We also have publish subscribe. So, for instance, a tap, and we'll see examples of this shortly. When you tap into a stream, that is by definition a publish subscribe environment, because we could have multiple streams could tap into another stream. By default, when we create a publish subscribe consumer, it uses an auto-delete queue. It's very similar. We're using the same paradigm as JMS topics, non-durable JMS topics by default, which basically means if you're not a subscriber to a topic, then you don't get any messages. There's nothing backed up for you. When you subscribe to a topic, then you'll get everything while you're subscribed. If you unsubscribe, it goes away. So we're simulating that environment in XD with this durable subscription notion, where by default it's false, which means that the queue that's created for a tap is auto-delete. So when that consumer goes away, when we unbind that module, the queue is deleted by RabbitMQ. If you set durable subscription to true, then instead of creating an auto-delete queue, we create a fixed, a non-auto-delete queue that will survive the module going down. So then when you rebind that module or restart that tap stream, you'll get any messages that you've missed. Again, this can be overridden on an individual stream basis in the deployment properties. But we can set it up in the bus properties, the server's YAML file for default action. And then the other one that's interesting is this republish the DLQ. As I said, the default process is to basically throw an exception back to the container. The container tells RabbitMQ to reject this message and don't requeue it. And when we say don't requeue it, then it will be routed to the dead letter exchange and hence to the queue as long as one has been provisioned. However, there were some limitations with that, is that you really don't know, well, what caused this message to fail, for example. Why? So it's because the Rabbit doesn't make any changes to that message, it just forwards it to the dead letter queue. With this republish the DLQ, we're using a facility within Spring AMQP, which is a republishing message recover. A message recover is sort of part of the Spring retry mechanism, that when retries are exhausted, the default is to throw this AMQP reject and don't requeue exception, which instructs the container to tell Rabbit to requeue it. When we set this to true, we provision a republishing message recoverer, which effectively takes the onus away from Rabbit, and we write that failed message to the dead letter queue. And the benefit of doing that is you get additional information in headers, such as the stack trace and the cause and the reasons for why the failure occurred. So, with that said, let's just take a look at some of this stuff. Now, has anybody played with Spring Flow for XD? Anybody know about Spring Flow for XD? This is available on the project page. Let me see. There's a beta download for this on the XD project page. You go to XD, and here's this download instruction. Basically, what you do is you download it and replace the UI jar in the XD lib folder. So I'm going to be using Flow for XD, and then I'm going to give you a little bit of a flavor of what's coming for Spring integration in terms of Flow. So let's take a look. So when you have the Flow-enabled jar, there's an additional tab that comes up on the streams page of the admin UI. And here now we can actually provision our flows. Now I'm going to do a simple time. I'm going to add a couple of transformers. And then just write it to a log. And as you can see now, this is building the flow as we go along. I'm going to make a few changes here, though. There we go. I'm going to change. first thing, you can't have two processes in a stream with the same name, so I'm just going to change the name of this transformer. I'm going to call it add text, and I'm going to add the time is plus payload. The time source just emits a string with the current time of day. So this first transformer is going to add some text to it, and as you can see, the DSL is updated in real time based on what we did here. So now we have this add text label for this transformer, so that they're now unique. And the second transformer, I'm going to call this upcase, and this is just going to simply payload to uppercase. We're just going to upcase the flow. So let's go ahead and deploy that. I gave it a label here just as a shortcut, because when we go to create stream, we have to give the stream a name. If you say TikTok equals in the DSL, it actually applies the name to it. And I'm going to deploy it. And if we go to our single node container here, we can now see this TikTok flow is spitting out the time is in uppercase, because we added the time is, we then uppercased it, and we sent it out. Now let's take a look at, well, what did this actually do? I'm gonna stop the flow for a minute because, well, no, I'll leave it running. So let's see what did that do in terms of RabbitMQ. So let's go over to the Rabbit console here, and as you can see, we have three queues, or three pipes, or time, pipe, transform, pipe, log. So each of those pipes is represented by a queue, and this is all configurable, but the default prefix is xdbus, and then dot stream name, and then the position of the pipe in the stream. So 0 is the first pipe, 1 is the second, and 2 is the third. And as you can see, I had that auto bind DLQ configured, so we've created the dead letter queues for these queues as well. And Rabbit has actually showed us here that we have dead letter exchange and the dead letter key. So let's just go and look to see exactly what we did there. And we can see we have this dead letter exchange called xdbus.dlx, and then the routing key is the name of the queue, because when the message fails, we need to tell it how to route to it. So we're routing with the original queue name, and that routes to the dead letter queue. At this point, there are no, we haven't added any exchanges, except for the dead letter exchange, of course. We had to provision that. But we don't need any exchanges. All of the routing within the message bus is just using the default exchange and the queue name for doing the routing. Any questions on that so far? Yes? No, that's shared across all the streams. Yeah. So let's now take a look. Let's go and add a tap to this stream. So I'm going to, because I'm lazy, I'm actually going to use the UI. Drag this tap onto here. Now it just gives us an initial name. I want to tap the stream called TikTok, and by default it's going to tap at the first pipe. And I'm just going to write that to the log. So a simple tap and create stream. I didn't give it an equal, so I'll just call it tapper. And now now we're getting 2 logs. We're getting the time is, we shout in the time is because of the upcase, and then the tapper is just sending out the log. You can see here the 2015, just the time, because we're tapping that first pipe in the tap in the main stream, TikTok stream. So let's take a look at what that did from a RabbitMQ perspective. So now we have the queue for the tap stream. That's now that greater than sign. It basically is saying that that's the named channel that the tap is writing to, and then we're consuming from that, and again writing it to the log. As you can see, it's been provisioned as an auto delete queue. So when I stop that, if I undeploy that tap, we're just going back to the regular stream being logged now, and that tap queue has gone away. The other thing that should be interesting to look at is the exchanges. What we do with taps is create a fanout exchange, which is basically a publish-subscribe notion where any taps can subscribe to that, but we're not actually writing to it. You see how when I undeployed, we're not unconditionally sending to that tap. XD has got the smarts to say, is there actually somebody on the other end? We don't currently have that's one area that we need to look at in the Spring Cloud Stream environment, but at least in XD right now, that's the mechanism that we use. We actually send a message back to the plugin that handles the modules that says, though, the last tap consumer has gone away. So if I restart or redeploy that tap, I'm not going to set any properties, and now we've got tap started again. We have our tap stream has been recreated, auto delete again, and now we can see that because the system has detected that there's a new consumer on the tap stream, we start writing to that exchange again. So if I go ahead and create another stream, tapper 2, again, it's easier to drag and drop. Oh, let me get rid of that. Tapper 2, and I'm just going to create another tap that's really doing the same thing. I'm going to deploy that. And you can see that we now have two queues, tapper and tapper 2, that are listening to the same tap. But of course, we only have the one exchange because it's a fanout. So we don't create an exchange for everyone. The stream that's being tapped, when it detects that there's at least one tap consumer, it starts right into this fanout exchange. And you can see the message rate. The time source by default is going to emit the time once a second. So as you can see, our message rate into this exchange is 1 a second, but the message rate out is now 2 a second. But the other thing we could do is describe what happens if we have a third tap, and I'm going to call it tapper 3. And I'm going to deploy this, but I'm not going to deploy it here because Flow doesn't give me the ability to set properties. So I'm just going to create this stream, tap of 3, go back to the definitions, and I'm going to deploy it. I'm going to set a deployment property. So remember that this stream really only consists of a single module called log. That does cause some confusion. Tap greater than module is a single module stream. The tap part is really just the named channel. There is only one module in here. So if I say module log consumer, what did I call it? It's durable subscription equals true. I deploy that. We're now seeing tap of 3 in our log, and if we go to Rabbit, again we still got the one fanout exchange. It's got 3 queues bound to it: tapper, tapper 2, and tapper 3, and the tapper 3. The tapper 3 queue is now durable. It's not auto delete. So when we undeploy that tapper 3 stream, actually let me just go and undeploy all of them. Tapper 2, and tapper 3. We now find that the auto delete queues are gone, but our tapper 3 queue is has a message in it, but it's not actually receiving messages because it's undeployed. And the tap stream is still not writing to it. So it really doesn't. Having the durable subscription doesn't mean you will get every message, but it will mean you'll get every message as long as the system's up, or as long as there's at least one subscriber to that channel. But if we redeploy tapper 3, and of course I have to do the deployment property again. Module log consumer he just reconnects to that existing queue and gets that old message that was in there. So how does all this work? So in the Rabbit message bus, let me see, I'm not used to this big screen. Let's see, go to the outline. Just take a look at the bind consumer. We get stuff like properties, like that durable subscription, and we effectively are going through this declare queue if not present. We have this auto bind DLQ, and we're just leveraging existing Spring AMQP capabilities, the Rabbit admin, to create these queues. Um, and as I say, when we do that, and then we also have this notion of direct binding, that if two modules are in the same container, then we can actually avoid going through Rabbit altogether and just bind the two together at that point. So that's all well and good. We now go and let's say we'll just destroy all of these modules, or these streams, should I say. One thing you'll notice is that we actually don't go through and delete any of these infrastructure. The reason for that is you might be undeploying, or you might be destroying the stream because you want to recreate it. There might be in-process messages, so the framework doesn't make any assumptions of that these queues can be deleted. So we do provide, or XD provides it's not currently built into the shell, but XD does provide a REST endpoint where you can say, okay, delete everything in Rabbit for this TikTok stream. And when you do that, you get back a JSON message that contains which queues were deleted and which exchanges. You can see we actually got rid of that. But cannot delete the exchange TikTok because we still have this Tapper 3. The Tapper 3 queue is still tied to that. So I'm gonna get rid of Tapper 3. That'll get rid of its queue, and then I can get rid of the TikTok. And here we see these queues were removed and this exchange. So we do provide you a mechanism to clean up. It's just that it's not automated for that reason. And of course, the dead letter exchange doesn't get removed either. Any questions on that so far? Okay, so that's really describes what goes on within XD and what will happen with the new Spring Cloud data flow with binding these modules together using Rabbit. I now want to switch to a little bit, talk a little bit about some of the new features that we added into Spring integration in 4.2, which was released last week. Anybody already upgraded to 4.2? Good man. I don't know if you got that Skype message yesterday, Taylor, but I fixed that problem with the metrics. Let's see. So I really want to emphasize that we do pay attention to Stack Overflow and questions, and we do try and be responsive when people have specific questions or requests. And recently, or maybe, I don't know, a few months ago, somebody was asking about, well, how do I've got an HTTP request. I want to do some asynchronous work, and but hold up the HTTP thread until these asynchronous processes have done. And we really didn't have anything in the framework to do that. It's relatively easy to put together a user component, but that wasn't the first time a request like that had come up. So one of the things that we looked at was introducing this new component called a barrier, or thread barrier. What it does, and this specific use case was RabbitMQ based, and it was specifically to wait until we got publisher confirms back from Rabbit that Rabbit had actually secured the message. Oh, really? Okay. Well, I was going to go back into Stack Overflow and say, hey, the component's there now. Yeah. So there's two things. So okay, you've got an HTTP request. You want to make sure that the message has been secured in Rabbit before you actually reply to the user. Now you can turn on transactions, right? I mean, just enable transactions in Rabbit, and the thread will block. Like you do the send, and it'll block, and then when Rabbit's got it, you'll get the on the commit. We'll block on the commit until Rabbit has confirmed that it's got the message. So let's take a look at what we've done in terms of, there's a new sample app called Barrier, and let's just take a look at its configuration. This sample sends, we got an HTTP request with A, B, C. The sample full page. So we have the request comes in. Let's see, where are we? I added some of the extra code so I can call it from a browser, but let's just look at here. So we've got this process channel. So basically the HTTP request sends it to this sends it to receive channel. Receive channel is okay. Receive channel. We add some. We need, in order to do this barrier process, we need something to correlate the message, because the barrier basically is it's almost like a rendezvous channel where two threads are communicating, and we need something to correlate. Okay, when this correlation ID comes back, we release the first thread. So the receive channel, first thing we do is create a correlation header, and all we do is copy the message's ID into that correlation, and then we send it to a pub sub channel. Now, as you know, and this is another common question that we get, is that I want to do something after I've called an outbound channel adapter. How do I do that? Because an outbound channel adapter, by definition, is a one-way integration. There is no reply for it. So a common pattern for that is to make the last channel in the flow a publish-subscribe channel, and we see we have two processes, or two endpoints are bound to that channel. The first one's a chain, and then the second one is this barrier component. So that the first, and you notice that we use the order attribute, so that typically you don't need it because it will be in the order in that they're defined. I tend to prefer to explicitly add orders, because it makes it clear to casual readers what's going on. So the subscribers on this process channel, order equals 1. We're going to do this. First thing we do is I get rid of a couple of headers, like the content type, content length. We then split it on the common. Remember, we sent ABC, and then we're just sending it to Rabbit. So we're just sending these messages to this queue. Well, it's actually called barrier sample queue. And to enable publisher confirms, we have to have a confirmation correlation expression. We have a confirmation ACK channel and NAC. So if we get a NAC back from Rabbit, we'll send it to the NAC channel. If we get an ACK, it goes to the NAC. I'm sending them both to the confirmation channel. Another thing that's interesting is that the correlation expression is this. And this in spell, in this context, is the message. So we actually want to get back, the correlation expression is something that your application needs to be able to know, well, which message was successfully published. It's easier, or it's very common just to say, just give me the whole message back. That'll tell me what's been published. So the other thing you have to do to get publisher confirms is on the connection factory, you have to set publish confirms. Now I'm using Spring Boot here, And Spring Boot currently doesn't have support for auto-configuring the publisher confirms property. I opened an issue. You see there's an issue here in Spring Boot asking them to add that. So what I did after the application initializes, I'm just going in and changing the publisher confirm, setting it to 2, and I'm calling reset connection so that basically we'll reconnect with publisher confirms enabled. So now we do that. We send our message to Rabbit. We've set the correlation expression up to return the message on the ACK channel. And a change that we've made in 4.2, anybody that's using publisher confirms need to be aware that in 4.2, if the correlation data is a message, then it's that message or a message based on that message is received. Previously, we would wrap that message in another message, right? But now it actually has the smart say, if it's already a message, then take that message, add the ACK header, and return that message. So it's no longer this sort of nested message. So what happens after that? So we've sent our message, we've done a split, we've written our 3 messages to RabbitMQ, and now we go to our second subscriber to this process channel, which is this new barrier component. And what that we have a correlation strategy expression to say we're going to correlate on this ACK correlation ID header in the message. So that now is going to sit there and just suspend. The thread's going to suspend for up to 10 seconds to wait for the correlation data to come back. Back in our outbound channel adapter, when the ACKs come back from Rabbit to say, yeah, I've got these messages, they go to this Conformations channel. And the Conformations channel basically is just an aggregator. It's just going to, when we did the split up here, we're using a standard splitter which sets standard correlation data in the messages. So things like sequence size, sequence number, and a correlation ID are all set up for us. So we don't need anything special in the aggregator. It will just use those default correlation headers to know, and the default release strategy, sequence size release strategy to release the message. The ACK aggregator itself, if I just go show you what that does, all this does, so when the 3 ACKs come back, now remember we're going to get basically the 3 original messages plus a header which indicates whether it was an ACK or a NACK. So all this aggregator does, so the aggregator, obviously we're A, B, C, the splitter gave us 3 messages, so we'll have a sequence size of 3. So when the release strategy says it's okay to release this message, or this group, because we have the 3 replies back, then it's going to invoke this message group processor to actually, what's the aggregator going to emit after that? And this message group will be those 3 messages come back with the ACK headers. So all it does is just iterate over those messages and builds a string that just says of the original payload, and then whether the ACK was successful, whether it was a successful ACK or not. When so now the aggregator releases the group. We now get a single message coming out with the aggregated reply, and in order to release the original HTTP thread, we just invoke that barrier, the trigger method on that barrier, the message handler within the barrier. Okay, because we've already got the correlation ID, the ACK headers set up, so we have that right stuff, and so we have this barrier component. We just use an outbound channel adapter on barrier.handler, and we invoke the trigger method. That will then release the thread that came in with the original HTTP request. When that thread's released, it's going to send something to the output channel. And by default, that something is a collection of messages, i.e. the original input message and the message that was the trigger to release that message. So in this case, we really are just going to discard the input message. So when this barrier releases, we go to this transformer, which just transforms the collection of messages just to the second message, which is our reply. And then standard Spring integration reply processing works by releasing this, sending the reply back to the original HTTP inbound gateway, and that goes back to the user. So let's take a look at it. What this Spring Boot app does is we basically have two Spring Boot application contexts. We've got the server side, which runs. It's obviously a web-based one because we've got an HTTP inbound adapter, inbound gateway, and then we have a client context, which is obviously not a web app, and we have a gateway. We send the ABC. So we're going to expect to get back this correlated reply. So going over to the boot dashboard here, let's just run this, and hopefully it'll all work. Here we go. So that showed how we do we can suspend a thread until any asynchronous process on the back end completes, and then resume the thread, in this case, to send the HTTP reply. Any questions? Pretty straightforward, huh? Good. Okay. One thing I was meant to do this while we were talking about XD, but let's just go ahead and do it now. We were using Flow for XD to build our XD streams. The amazing Andy Clement has now focused his attention on, well, what can we do for Spring integration in terms of Flow? This is all still very, very new. That's why that legal slide was on there. There was no promises on when this is going to be delivered, but there's some good functionality here already. So let's take a look at what we have. So we decided because of resources. That it's the flow today is based on the Java DSL that Artem was talking about in the session before this. We have a simple flow here, a simple Java DSL integration flow that has a file inbound channel adapter that reads files from temp/in. It does a transformation on it, file to string, basically pulls that file into memory. It's changing DOS new lines to Unix new lines, and then writing it to a directory temp out. So let's take a look at Flow for Spring integration. Let's just paste that Java DSL in here, and as you can see, we have our inbound channel adapter, transformer, and the screen's not big enough, and in fact, I think there's a zoom on here somewhere. What's that? Oh, yeah, we can just drag it, yeah. There we go. Yeah. So as I said, it's still a work in process. Let's go the other way. Let's just delete that, and we can actually build a flow or build a Spring integration flow, and as you can see, it actually creates the Java DSL as we go along. We call that files. Let me do. And it's generated the DSL for that. Cool stuff. Huh? So that's now, of course, we've had for some time, and I think IDEA has something similar. The Spring integration visualization in here. I can go to the integration graph in here, but there's some limitations with it in terms of you can only represent a single file. The flow stuff is going to be able to, and what we eventually, if you have multiple flows, we were talking to somebody earlier about you'd want to really compartmentalize your flows, make them into smaller flows. Eventually, he'll support that in a single Java class, and maybe even multiple classes, and wire them together into a flow. So that's just a flavor. I mean, hopefully that was good to see. And of course, it will have the sort of attributes as well. So like on, if we look at the, we can add things like expression, and just so you can actually go and assemble the whole flow visually. Okay, let me look at a couple more things. Spring Integration 4.2. You may have seen, or may have sort of looked at the what's new and said, well, there's not a whole lot going on, and it's not a huge release this time. As I said, I spent a lot of time on XD this year, so we had a little less time to spend on Spring Integration than we have in the past. However, one of the key outcomes of XD, obviously XD is extreme data, that we did do quite a number of significant performance improvements in Spring Integration that we found while doing some micro benchmarking in Spring XD. One of the biggest areas that we found most critical was the metrics gathering in JMX. The way it was implemented since 2.0, I think it was added in 2.0 JMX support, was via proxies. Every time, so if you said I want to capture statistics for a channel, then that channel was wrapped in a proxy that captured the statistics. And if ever you had JMX turned on, if you saw any exception, Spring Integration exception stack traces are pretty scary to begin with. But if you have JMX enabled, they were really, really scary. I think for a channel, it added 13 stack frames. And for a message handle, it was 12 stack frames were added for for every time we went through metrics. So there was the whole proxying and the reflective based code was just not good from a runtime performance perspective. So this this element here, this sort of major JMX rework was done, and we can go through the details exactly what was changed. But the significant difference is that now metrics are you don't need JMX to capture metrics anymore, and they're configurable. Well, you don't need JMX. The metrics are actually maintained directly within the object, message handler, message source, channel, rather than being proxied. So we got rid of all those extra stack frames in the traces. Even if you have JMX enabled, you don't see all those stack traces. And it's much more performant. I mean, it's just very much more performant. But so you don't need JMX, and you can configure metrics on an individual component or individual components. You can say, I want to capture stats on all my channels that have input in them, or you can give it patterns and say, I want to capture statistics. There's also two levels of metrics. You can enable counts, which is just a message count, how many messages have gone through a particular component, or you can enable full stats, which calculates the whole response time, moving averages, and all that good stuff. And that in itself was also significantly rewritten, because previously the standard deviation and the moving average and all that was actually calculated on every send. So every time we sent a message, all those stats were sort of dynamically recalculated. So and this was exposed very early on in XD that this was obviously, now in a grand scheme of things, I mean, don't get me wrong, it's not terrible, but when you're doing micro benchmarking, where you're not doing any real work and the only thing you're testing is stuff going through the frame, it looked horrible, right? Now, as I said, as soon as you do any real work in there, you've got some transformer that's doing JSON parsing or XML transformation, anything like that, then this stuff really becomes noise. But in some of the XD scenarios where we're really just trying to pipe stuff through, HTTP to HDFS or whatever, where we weren't really doing any processing on the data, just moving the data, then it became a significant overhead. So what happens now is the buckets are maintained, the statistical data is captured at runtime, but it's only calculated from the perspective of moving averages and standard deviations of when you actually retrieve it. So I mean, it sounds like a simple thing, but nobody had really gone through and done that kind of level of micro benchmarking on Spring integration before we did it with XD. So that's another very big change in 4.2 is just the performance that we have there.
Can you explain the linkage between what you're doing at Zookeeper and Spring integration and what's done in XD?
Did I give you $20? That was going to be my next my next demo. Yeah. I don't know if it was never really widely publicized, but I was doing in my early days with VMware prior to the Pivotal spin-off. I was doing some consulting for EMC, which is our the sort of parent company, and they were replacing all of their internal integration systems to use Spring integration. So throughout the whole company, everything uses Spring integration. And one of their requirements was a couple of requirements. One was a notion of a single consumer, so they want strict ordering of messages going through the system, and they wanted resiliency. So, so if let's say an invoice is going through the system, they wanted to make sure that only one message that works on that invoice would be in process at a time. So that was one use case that we solved for them, and there's a project in GitHub. It's not really part of the framework, but it's up there, and some people have used it. Spring Integration Cluster, I think it's called. But the other one was the resiliency. How do we make sure that we only have one consuming from a JMS queue, but if that one goes down, start another one, right? And in those days, Zookeeper was still a little it wasn't really very mature. So we ended up with writing our own sort of custom mechanism to effectively do heartbeats and to fire up another, or have a hot standby that was sitting there, wasn't really consuming, but it would detect that the system's gone down. Well, now, with our experience with Zookeeper with XD, and obviously it's a few years further along, we now have support for Zookeeper in XD, in Spring Integration proper. And the three, we have this general abstraction called a lock registry that we use within the aggregator. Typically, it's probably the most commonplace, where if we have multiple messages coming in for the same correlation ID, then we use a lock registry to say, well, we can only have one, we can only manipulate the message group with that correlation ID one at a time. So we have this notion of a lock registry that we use to do that, and we have a number of implementations that support doing that across a cluster aggregate. So you could have a Redis-based one. I think we have a Gemfire. We have a Gemfire lock registry, and now we have a Zookeeper lock registry. So we can, and this is all based on the curator framework, which provides a little higher level abstraction over that. So we can have a cluster. You can have a cluster of aggregators using a Zookeeper lock registry to make sure we only really, there's only one thread across the cluster manipulating a group at the same time. And the metadata store, that's for things like file system persistent file list filters and things like that, so that we can share metadata across instances. Metadata stores are used in a number of components in Spring Integration, things like the feed source and Twitter source for keeping track of what was the last message that I received. But the one that's probably the most interesting here is getting back to my EMC story, is this leadership capability. So what have we done there? So let me go to the test case. Is the easiest way to show this. Config. XML. So with Spring Integration 4.2, we have a new property on. What happened? We lose power? Huh. Wow. Oh. Okay. Is anybody familiar with Smart Lifecycle in Spring? So Smart Lifecycle, well, there's an interface called Lifecycle where Spring automatically will start and stop beans that are in Lifecycle. Has methods start and stop on them. So when you do application context start, it will actually find all the beans with a Lifecycle and start them. Smart Lifecycle has got a couple extra methods on it, such as auto startup and phase. And auto startup really tells Spring, should I automatically start these beans when the application context starts, before anybody actually issues .start on the application context. I would say every 99.99% of the components in Spring Integration implement smart lifecycle. That's how we start and stop adapters automatically. You see, auto startup equals false, right? That's how we say, don't start this inbound channel adapter. 4.2, anything that has these smart lifecycle attributes on them, auto startup and phase, now has this role attribute. And what that does is it puts this endpoint into that role. It says assign this endpoint, in this case ICA, the role of cluster. The Zookeeper support is this leader-listener element. We have to point it to a Zookeeper client, which is configured elsewhere. This is where this information is stored within Zookeeper, and again it has this role cluster, and this bean is also auto startup equals false. Now, what actually happens is, and we go to the actual test case that runs this. The first thing we do is we actually start this leader. There's this leader initiator. That ZK leader element in XML creates a leader initiator element component. We start that, and what happens is now we deploy this application in multiple servers, and one of those instances will be elected leader by Zookeeper. Again, it's just using the curator layer still on top of Zookeeper. And when that happens, if we get elected leader, then Spring integration will then go find all of the smart lifecycle beans in the application context that are in the role that this ZK leader listener is in, and start them. So now we have that resiliency. So we have, it's effectively given us a hot standby mechanism. If we use some kind of shared broker to distribute the work, such as Rabbit, we can now have a file inbound channel adapter that's monitoring an NFS share, for example, when we only have one of them that's actually running, and then distributing the work using RabbitMQ. So you'd have your inbound channel adapter, a Rabbit back channel, and then downstream elements. And so they're all actively, all those instances are actively involved in the work, but only one of them is monitoring the file system at the time. And if that one goes down, another instance gets elected leader, and it will go and then start its channel adapter. So I think this is a much cleaner solution than what we came up with EMC. But as I said, that was quite a bit more complicated, and it was sort of really before Zookeeper was really mature enough. But I think this is now something that could be widely used. The reason we have this, you can also have multiple leaders. Of course, you can have as many roles as you want. So that's really what that flexibility is there for. So I think that's really all I was going to cover in terms of the new stuff. Let's just see if there's anything else that might be interesting. The thread barrier. We have Stomp client now. Let's see. Another one, security context propagation. That's a new feature that could be useful. Everybody that's familiar with Spring Security, I'm sure, is aware that when you authenticate with the server, the authorization or the authentication object is bound to the thread. So as soon as you go async, if you send a message to a queue channel or an executed channel, you've kind of lost that security context. So really it's sort of like similar to transactions. In the old world, if you go async, then you lose that security context. With this feature now, we can actually propagate over an executed channel or a queue channel where the consuming thread will inherit the security context from the sending thread, and the framework takes care of automatically cleaning that up. So when that thread exits or goes back into the task executor pool, we make sure we clear that stuff so there's no danger of sort of dirty context being around. The file splitter is an interesting new component that now Artem was showing that in his demonstration, where you can now it really only works with text-based files, but it will just read a file. So in the old days, the only thing we really had was a file to string transformer, which would take read the whole file into memory. If you've got a very large file, that might not be so smart. So we have iterator-based splitters now, and the file splitter basically implements that and basically reads the file a line at a time and then emits them as messages. So that's another useful change. As I said, a lot of this stuff was internal performance. JMX rework was a big part of the performance. There were other performance changes as well, particularly in the area of aggregation. We found some fairly important bottlenecks for aggregation to the way that message groups are being used. So I think that's really all I have, unless there are any more questions. Yes. Well, I mean, Spring Cloud Stream really builds on. I mean, it's just using Spring integration. I mean, Spring Cloud Stream is like the XD modules that they're all based on Spring integration. There are I can at least show you. Let me see. So well here this is the time source of that stuff that I was doing. So it's just using. It's just a Spring integration inbound channel adapter. So you can use XML or Java annotations or the DSL, in fact. So if we go to, let's see. Oops. XD modules. There's actually a, where is it? Oh, no, it's in samples, I think. There's actually a sample based on the DSL. So if we go look at that sample, why didn't I? Okay. So it's an XD module. This one is a processor that reads input, does a transformation on it, and sends it to the output channel. So there's not really any conflict between XD, Spring Cloud Stream and Spring integration. As I said, I mean, in fact, for this last year, most of the work in Spring integration has been driven by requirements from Spring XD, because it's using integration in some ways that haven't been used before, and so it's sort of driven some requirements into there. But it's not going away. It's not like it's not being replaced by Spring Cloud Stream. It's just that it's just like Spring Framework itself is a component that Spring integration sits on top of. Then Spring Cloud Stream is just another layer of abstraction on top of Spring integration. Anything else? Okay, so thanks for coming, and please continue to use the framework. and give us your feedback.